Meet Long. He was reading an article about Belgian waffles from a local newspaper and saw something shocking. Only 10% of Phamville residents say Belgian waffles are their favorite food? Bogus! Many Phamville residents love Belgian waffles. Long goes around Phamville and asks 100 random residents if Belgian waffles are their favorite food. He finds that 17 of them say Belgian waffles are their favorite food. So now he has this data and info. What should he do with it? Long, let me introduce you to significance tests, specifically one proportion z test with one sample. Significance tests are about testing out hypotheses and are integral in statistics. There are many different types of significance tests, and the purpose of doing them is to determine the validity of a statistical claim and conclude something about the said or alternate claim. The first part of any significance test is to state your hypothesis, significance level, and other important variables. For this z-test for one population proportion, there are 4 important variables to consider. P, which represents the true or actual proportion of something for the specific population that you sample from. For these tests, we assume P to be the proportion that is already claimed. The significance level, also written as alpha, we set it to a small value like 0.05. It will help us later when we come to a conclusion at the end of this test. The null hypothesis, which is written as H0, is where we assume the P variable will equal the proportion that is claimed. The alternative hypothesis, which is written as HA, is where we assume that P is less than, more than, or different from the claimed proportion depending on the situation. The next part of a significance test is checking some conditions. For this specific situation, there are 3 conditions. The sample you use for this test must be random. These 2 statements must be true. N is the sample size and we already know P. Large samples are important. The population size has to be at least 10 times the sample size. Next, we'll use this formula to calculate the standardized test statistic z rounded to the nearest hundredth. P hat is the proportion you get from your sample. We use this value for this table where we match the z value to the correct value in the table to be used in the next step. Match the values in the ones and tenths place of the z value to the correct value on the leftmost column of the table, and the value in the hundredths place to the correct value on the top row. Find where these values intersect in the table and use this intersected value in the next step. The next step is determining the p-value, the probability of obtaining a result at least as extreme as an observed sample result in a significance test if we assume the null hypothesis is true. If our alternate hypothesis says p is less than claimed, we'll use the value we just obtained as the p-value. If our alternate hypothesis says p is more than claimed, our p-value is 1 minus the value we obtained. If our alternate hypothesis says p is not as claimed, meaning either more or less than claimed, our p-value is the value we obtained times 2. Last, make a conclusion using the p-value and significance level. If the p-value is greater than the significance level, we'll fail to reject the null hypothesis. If the p-value is less than the significance level, we'll reject the null hypothesis. With this info, Long can confront the local newspaper about the potential misinformation in their article. Thank you, significance tests.